boys and girls. This is your Unit 9 Rapid Review, coming to you from Mrs. Johnson in room 254 at Northwest High School. Alright, so what did we learn this unit? We learned how to do a two-proportion confidence interval, a two-proportion hypothesis test, and how to do margin of error problems with two proportions. Alright, so let's say we do want to estimate P1 minus P2 from two populations, and we have to use P hat 1 minus P hat 2. How do we do it? Well, we must do all four steps of a two-proportion confidence interval. So let's try one together. The journal Science News investigated that smoking rates for male and female diabetics. They found in a random sample of 500 males that 215 of them smoked cigarettes. They also found in a random sample of 500 females that 170 of them smoked cigarettes. Construct the 98% confidence interval estimate for the difference in the smoking rates between male and female diabetics. Could you please pause this video now and do this on your own? Alright, so here's the answer. Step 1. You need to tell me what you want to do. I want to find an interval with 98% confidence that will contain the difference in proportions between male and female diabetics that smoke. If you notice, I put in parentheses proportion of male P sub M and female P sub F. You can do that if you would like, so to identify variables. You can also use P sub 1 and P sub 2. The parameter of interest is always what you care about, and we care about the difference in proportion between male and female diabetics that smoke. If you look at your step 2, you need a random sample for both, and that was given. Independent samples for both. We can assume that because of the random samples. And you need to verify all of the n times p hat 1 and the n times 1 minus p hat 1 has to be greater than or equal to 10, and I showed all my work. And n times p hat 2 has to be greater than or equal to 10, and I showed my work. N times 1 minus p hat 2 is greater than or equal to 10, and I showed my work. Make sure that you are showing all of these, okay? Then, and I actually put this at the bottom, but some of you remember it as the third one. Population must be at least 10N for both. We can assume there's at least 5,000 male and 5,000 female diabetics because I had 500 in each of my sample sizes. I did write now that I can use, that I've satisfied my conditions, I can use the normal model or z-scores to create a two-proportion confidence interval. Step 3, you have to write this equation, okay? And I'm going to show you at the end of this video where to find this equation on your formula sheet. Then you have to plug in all these numbers. Now some of you are wondering where I got this z-score. If you have a 98% confidence interval, the middle is 98%, so on each side you only have 1%. So I did inverse norm 0.01. Then you plug in all of these numbers, and actually I go to stat, tests, B in my calculator, and I get the answer instead of spending the time to actually crunch that in my calculator with parentheses. Then you write the step 4. I am 98% confident that the difference in proportion between male and female diabetics that smoke is between, and I turned it into percent. If you want to, you can leave it as proportion, but I did 1.9% and 16.1%. Again, where can you check your work? Under stat test B, because it says two proportion interval. You do need to know what the following mean. A positive interval means that the first proportion is higher. A negative interval means that we think that the second proportion is higher. If it's positive interval, then we have no certainty as to which one will be higher with that confidence level. You also need to be able to do a margin of error problem. Assume that n1 equals n2. Write the equation and fill in, and don't forget to round your n up for both samples. This is just like number 3 on the review sheet, if you look back at it. And the answer to the reviews will be on Edline as well. To test a claim about P1 minus P2, you must use a two-proportion hypothesis test and show all 5 steps. So let's do another one together. Suppose a study is conducted to compare the service provided by manufacturers to home PC users and work PC owners. Of 220 home PC owners who had trouble, 98 reported that their problem was not resolved satisfactorily. Of 180 work PC owners who experienced difficulty, 52 reported that it was not resolved. At the 0.05 level of significance, did the home PC units experience more problems that could not be resolved by the manufacturer? Stop the video now and do the problem. All right, so let me show you all the steps here. Step one is what you want to know is the first sentence, and the parameter of interest is the second sentence. So I want to know if there's a larger proportion of home PC owners that experience problems that cannot be resolved versus work PC owners. Parameter of interest is the difference in proportion of home PC owners and work PC owners that experience problems that cannot be resolved. Step two, the null hypothesis H sub 0 is probability of homeowners, okay, minus the probability of work owners equals 0. Okay, you can define P sub H, P sub W in this step, or you could put it in parentheses up here in step 1. Now, the alternative is P sub H minus P sub W is greater than 0. And the reason it is because in the problem we thought that there's a larger proportion of homes that experience problem that couldn't be resolved. So that's greater than. Step 3. Step 3 is the exact same stuff that I had before, except it's, well, I don't know what just happened there. Okay. Step 3 is the exact same stuff that we did in the hypothesis test, except for a different number. So go ahead and you can pause it here and check your work, but I don't want to spend the time going over every little detail. But make sure you verify them all. Okay, step 4. Now, there's a new p hat in town, and it's underneath the square root. What is it? It's actually called the pooled p. And so what you do is you take both numerators and you add them. And then you take both denominators and you add them. And you put it into a fraction. Okay? And that goes on the bottom. I need to be able to see this, how you got it. Okay? And then you need to plug it into the bottom and take its complement. Okay? And then you guys should be able to fill in everything else. So you give me the equation, fill in the numbers. Then I go to stat test 6 and I actually just get the answer because I get really sick of just plugging and getting all these answers. The p-value, well, for this one we're going to go greater than that value, and I got a really small number because it says e to -4, but it's really times 10 to -4. Don't write e on your paper, that's calculator speak. And that's less than 0.05, so you should already have in your head that you're going to reject the null hypothesis. Okay, everybody gets confused by step 5, but I'm going to say it really slowly here, and maybe you can replay it. There are two sentences. One, you have to either tell me to reject or fail to reject the null hypothesis. Okay, the second sentence is telling me what a p-value is. Okay, so first sentence. We just said we're going to reject the null hypothesis, okay? So this is how I said it. At the 5% level of significance, okay, that's what I'm starting with, we reject the null hypothesis. Well, what does the null hypothesis say? Let's go back. The null hypothesis says that there's no difference between proportion of home computers that don't get resolved and proportion of work computers that don't get resolved. There's no difference between those two proportions. So that's how I said it. We reject the claim that there's no difference between the PC owners and the work owners that experience problems. Do you guys see that I'm just repeating what the null hypothesis means? I'm rejecting that. Then the second statement is the p-value. What is a p-value? It means that the probability of us obtaining our values, you know, like our statistics, our p-hats. It's the probability of us obtaining our p-hats if the null hypothesis is true. So that's what I said. If the null hypothesis, and I just wrote that the proportions are the same, is true. Just remember it like that. One of them tells you if you're going to reject or fail to reject the whole, and the second one is what is the p-value. All right, remember in a hypothesis test for this unit, there's only 3 types of alternative hypotheses that you can have. You can have less than 0, greater than 0, or not equal to 0. I also wanted to remind you that you do need to know what a p-value is, like I just said, what a type 1 error is, and a type 2 error is, and a power. The only thing you need to know about power is it's the complement of a type 2 error. It's correctly rejecting the null hypothesis, okay? And if you increase n or increase the level of significance, it increases your power. All right, so here's the formula sheet you're going to get, okay? So it's the 3rd sheet of the formula packet if you want to look at it to study. Now, for a confidence interval, it tells you to take the statistic. So what we're doing is p hat 1 minus p hat 2. That's the statistic, plus or minus z-score, times this. It says standard deviation. Now, go down, and this is the actual standard deviation, or the second part of your confidence interval that you're going to use. Now, up here it says standardized test statistic. For z-score, so for a hypothesis test, you do p hat 1 minus p hat 2. Don't worry about where it says minus parameter over one of these. But we're going to use this because remember the hoe is P1 equals P2. So you're going to use this. Now somebody's going to say to me, but Miss Johnson, I only have one square root. Guys, this is the same thing. If they just separated it, but it's the same exact thing. That's the denominator. So that might help you, or you can try and memorize it. All right, so I have an incentive. If everyone does well, like if I have no failures, meaning no like E's, then your class will receive either a donut party or a pizza party. All right, so there's your incentive. Good luck, everyone, and I'll see you tomorrow.